Good morning students. In this video we are going to see Unit 5 Acoustics from page number 65 to 67. Learning objectives: understand about Doppler effect, know about the expression for apparent frequency due to Doppler effect. Now let us recall the previous class portion. Reflection. What is called reflection? When sound waves travel in a given medium and strike the surface of another medium, they can be bounced back into the first medium. This phenomenon is known as reflection. Laws of reflection. State the laws of reflection. The incident wave, the normal to the reflecting surface, and the reflected wave at the point of incidence lie in the same plane. The angle of incidence is equal to the angle of reflection. Rarer medium and denser medium. What is meant by rarer medium and denser medium? The medium in which the velocity of sound increases compared to the other medium is called rarer medium. Here water is rarer medium compared to air for sound. The medium in which the velocity of sound decreased compared to other medium is called denser medium. Air is denser compared to water for sound. Echo. What is called echo? An echo is the sound produced by the reflection of the original sound from the various rigid surfaces such as walls, ceiling surfaces of mountains, etc. Applications for reflection of sound. What are the applications for reflection of sound? Soundboard, ear trumpet, megaphone. Now let us see today's class portion. Doppler effect. What is Doppler effect? The whistle of a fast moving train appears to increase in pitch as it approaches a stationary listener, and it appears to decrease as the train moves away from the listener. See this diagram. Here a vehicle is moving towards the listener. Here is a listener. A vehicle is moving towards a listener. So when the vehicle moving towards the listener, the pitch increases, the sound increases. Now here also a listener. Now a vehicle is moving away from the listener. Here the vehicle is moving away from the listener. Now what happens here? The sound. Here the pitch decreases, the sound decreases, low frequency and high frequency. A vehicle moving towards the listener, frequency is high. A vehicle moving away from the listener, a frequency is low. Now here an apparent change takes place in the frequency. The apparent change takes place in the frequency. This apparent change in frequency was first observed by Christian Doppler, an Austrian mathematician and physicist. He observed that the frequency of the sound as received by a listener is different from the original frequency produced by the source whenever there is a relative motion between the source and the listener. If there is a relative motion between the source and the listener, then only the frequency of the sound changes. The frequency of the sound received by a listener is different from the original frequency produced by the source, if there is a relative motion between the source and the listener. This is known as Doppler effect. Now let us see the relative motion between the source and the listener. What are the possibilities for the relative motion between the source and the listener? Here we have to see the first one. The listener moved towards or away from a stationary source. L is the listener and then S is the source. Now the listener moved towards the source. L, listener move towards the source. In this first diagram, the listener moved towards the source. The listener also moved away from the source. That is, the source is at rest. Now here the listener move away from the source. So the first possibility is the listener move towards the source or the listener move away from the source. Now what happens to the source? The source is at rest. source is at rest. So when the source is at rest, the listener move towards the source or the listener move away from the source. Second possibility, the source moves towards or away from a stationary listener. Now in this case, listener is at rest. In this case, listener is at rest. Now the source move towards the listener or the source move away from the listener. In the first diagram, source is moving towards the listener, and in the second diagram, source is moving away from the listener. Third one, both source and listener move towards or away from one another. See the first diagram, source and listener, both of them moving towards each other. Both of them moving towards each other. Source also moving, listener also moving. And then see in the second diagram, source and listener move away from each other. Source are moving away from each other and listener also moving away from each other. So in the third possibility, both the source and listener move towards or away from each other. Fourth possibility, the medium moves when both source and listener are at rest. Source and listener, both of them are rest. Then what happens to the medium? The medium moves. That is, the velocity moves. The velocity changes. Both the source and listener are at rest. So these are the four possibilities for the relative motion between source and listener. What are the four possibilities? The first one, listener move towards or away from a stationary source. The source move towards or away from a stationary listener. Third possibility, both source and listener move towards or away from one another. Fourth possibility, the medium moves when both source and listener are at rest. Now from this we have to state what is known as Doppler effect. Whenever there is a relative motion between a source and a listener. Relative motion means the source is moving, listener is at rest, or the listener is moving, source is at rest. So there is a relative motion between the source and the listener. The frequency of the sound heard by the listener is different from the original frequency of sound emitted by the source. So if there is a relative motion, the sound heard by the listener is different from the original frequency of sound emitted by the source. So if there is a change in frequency, then we have to say it is a Doppler effect. When the change in frequency takes place, if there is a relative motion between a source and a listener. Whenever there is a relative motion between a source and a listener, the frequency of the sound heard by the listener is different from the original frequency of sound emitted by the source. This is known as Doppler effect. Now the source in this diagram, source S and listener L, both of them are moving. Let S and L be the source and listener moving with velocities Vs and Vl. Source having velocity Vs and listener having velocity Vl. Consider the case of source and listener moving towards each other. Here the source and listener, both of them are moving towards each other. Now when both of them are moving towards each other, what happens to the distance between the source and the listener? The distance between the source and the listener decreases. So when the distance decreases, what happens to the frequency? The apparent frequency will be more than the actual source frequency. When the distance decreases, we have to hear the clear sound from the source. So when the distance increases, the source and the listener are moving towards each other, the distance decreases, then the apparent frequency will be more than the actual source frequency. Let n and n dash be the frequency of the sound heard by the source and the sound observed by the listener respectively. Now we have to take n is the frequency of the source and n dash is the frequency of the listener. N is the frequency of the source and then n dash is the frequency of the listener. Then what is the apparent frequency? The apparent frequency is n dash. So, the n dash is equal to V plus VL by V minus Vs n. Remember this formula, n dash is equal to, n dash is the apparent frequency, V is the velocity of the sound wave in the given medium. That is the velocity of the sound in given medium. What is V? Velocity of sound in given medium. And what is VL? Velocity of the listener. V is velocity of the source. And what is N? It is an actual frequency. N dash, it is an apparent frequency. So, if the source and listener are moving towards each other, then the expression for apparent frequency N dash is equal to V plus VL by V minus Vn into N, where V is the velocity of sound wave in the given medium. Now, let us see the expression for apparent frequency due to Doppler effect. What are the apparent frequency due to Doppler effect? Now, we have to consider the first case, that is the position. What is the position of the source and listener? In first expression, the position of the source and listener both are moving towards each other. Source moving toward the listener and then the listener also moving towards the source. In first case, both the source and listener are moving towards each other. Okay, when both the source and listener are moving towards each other, what about the distance and what about the frequency? Now, let us see. See here, the distance between source and listener decreases. When both of them are moving towards, the distance decreases. So, when the distance decreases, then the listener heard the sound very clearly. So, the apparent frequency is more than actual frequency. The apparent frequency is more than actual frequency. Then, what is the expression for actual frequency? The N dash is equal to V plus VL by V minus Vs into N. So, when both source and listener are moving towards each other, the distance between source and listener decreases and then the apparent frequency is more than actual frequency. Then what is the expression? N dash is equal to, that is the expression for apparent frequency, N dash is equal to V plus VL by V minus Vs into N. Remember this expression. The expressions are very important to do the problem in this lesson. N dash is equal to V plus VL by V minus Vs into N. N dash is the apparent frequency, V is the velocity of the medium, VL velocity of the listener, Vs velocity of the source and N is the actual frequency. Now, second expression. Now, in this case, the both source and listener move. Source and listener both are moving, but here both move away from each other. Source and listener move away from each other. See the arrow mark, both are moving away from each other. Then what is the changes takes place? What about the distance and apparent frequency? Distance between source and listener increases. And then apparent frequency is less than actual frequency. When we move away from the source or when we move away from the train, did you hear the sound of the train? No, we have to hear very less. So, we have to hear the very low sound. So, the apparent frequency is less than actual frequency. So, here the Vs and VL both are opposite to each other. In the first condition, both are moving towards. So, the direction will change like this. Now, in the second one, opposite direction. So, in the first, Vs and VL become opposite to that case 1. So, what is the case 1 formula? N dash is equal to V plus VL by V minus Vs. So, in this the plus becomes minus and then the minus becomes plus. So, N dash is equal to V minus VL by V plus Vs into N. when you remember the first expression, it is very easy for you to write the second expression. We have to change the sign. In the first expression, the VL is positive and here the VL is negative. And then in first expression, the Vs is negative and then here the Vs is positive. Why we have to change the sign? Because here both of them are moving away from each other. Now both source and listener move. They move one behind the other. See here, source and listener move one behind the other. That is, the source follows the listener. Source follows the listener. Now what happens to the frequency? Apparent frequency depends on the velocity of the source and the listener. When the source follow the listener fastly or slowly, depending upon that, they have to hear the sound. So the apparent frequency depends on the velocity of the source and then velocity of the listener, the speed of the source and the speed of the listener. So in this case, the Vs becomes opposite to that in case 2. In case 2, what is the expression for case 2? N dash is equal to V minus VL by V plus S into N. So in this, we have to change the sign for source alone. So V minus Vs. Next one, both source and listener move. They move one behind the other. That is, the listener follow the source. The listener follow the source. In previous condition, source follows the listener. And here, listener follows the source. So here also the apparent frequency depends upon the velocity of the source and the listener. So Vs and VL becomes opposite to that case 3. What is case 3 formula? N dash is equal to V minus VL by V minus Vs. So in case 3, minus VL and minus Vs. And in this, plus VL and plus Vs. That is, both are moving in opposite direction comparing to the previous condition. So we have to change the sign. So V plus VL by V plus Vs. Now next condition, source is at rest. Source is at rest, listener move towards the source. Listener is moving towards source. So the distance between the source and listener decreases. When one object is at rest and another object is moving, means the distance decreases. So here the apparent frequency is more than actual frequency. We already know when the distance decreases, apparent frequency increases. Now Vs becomes 0. Why it becomes 0? It is at rest. So in case 1, what is the case 1 formula? N dash is equal to V plus VL by V minus Vs. In that we have to put Vs is equal to 0. So the expression becomes N dash is equal to V plus VL by V into N. Both source and listener move. They move one behind the other. Listener follows the source. So apparent frequency depends on the velocities of the source and the listener. So Vs and VL become opposite to each other. So expression becomes N dash is equal to V plus VL by V plus Vs into N. This is the previous condition. And then next condition, source is at rest and then listener move towards the source. So when the listener move, what happens? The distance decreases. So here apparent frequency is more than actual frequency. So Vs becomes 0. So the first expression becomes V plus VL by V into N. Now next condition, source at rest. Listener move away from the source. In previous condition, listener move towards the source. Now here the listener move away from the source. So what happens to the distance? Distance increases. And what about the apparent frequency? It is less than the actual frequency. Now Vs is 0. Why? It is at rest. Source is at rest, so it becomes 0. So we have to change the second expression. In second expression, V minus VL by V plus S. In that Vs is equal to 0. So V minus VL by V. Why we are taking the second expression? In the second expression only both are moving away from each other. So when both are moving towards each other, we have to take the first expression. When both source and listener are moving away from each other, we have to take the second expression, and we have to change that according to the condition. So here listener move away from each other, so we have to take the second case, and then we have to put Vs is equal to 0. Listener at rest. Now in this, listener is at rest and then source move towards the listener. So when the source move towards the listener, what happens? Distance, yes, decreases. The distance between source and listener decreases. Now what about the apparent frequency? It is more than the actual frequency. So in this, which one becomes 0? Listener becomes 0. So which condition, which expression we have to take? First expression. Why? Source moving towards the listener. If both of them are moving towards means we have to take first expression. What is the first expression? V plus VL by V minus Vs into N. In that, VL becomes 0. So the remaining expression becomes V by V minus Vs into N. Now listener at rest. Source move away from the listener. Source move away from the listener. Then the distance becomes increases. The distance increases between source and listener. Apparent frequency is less than actual frequency. When the distance increases, apparent frequency decreases. Now which one is at rest? Listener. So the listener becomes 0. So when away means, which expression we have to take? Second expression. What is the second expression? V minus VL by V plus S. In that, VL becomes 0. So V by V plus Vs. Suppose the medium is moving with velocity w in the direction of the propagation of sound. That is, wind is moving with the velocity w in the direction of propagation of sound. Now the velocity of sound we have to taken as v, and it should be replaced with v plus w. That is the sound moving with the wind. So the velocity changes v plus w. If the medium moves in a direction opposite to the propagation of the sound, both the wind and sound both are in opposite directions, then the v should be replaced with v minus w. So when the wind is moving with a velocity w in the direction of the propagation of sound, now in this case the velocity of sound v should be replaced with v plus w. If the medium moves in a direction opposite to the propagation of sound, then v should be replaced with v minus w. Thank you, students.